I'm quiet here.
See, Betty set a good example. They're all sitting down.
I always set a good example.
Okay, our next guest speaker is someone that I've become, I guess, more personally acquainted with over the last 3 or 4 years because of, you always kind of, when bad things happen, you always look to find a good side of how things can turn out for you. A number of years ago, we were going through one of our depopulations, and it had come to my attention that Dr. Haley was looking for samples to work on some of his research when he was with Kansas. I had become acquainted with his name through my work on the American Cervid Alliance, and we talked quite regularly about some of these types of projects at work. And I said, well, this sounds like a perfect example for somebody to get involved. So I'd already laid a little bit of the groundwork for it, and as it turned out at the time, we were able to get approval to get some extra samples taken from these animals and taken and used in Dr. Haley's work. Now, that's part of the story, and now the other part of the story is that I've kind of grown fond of this guy because he's a big guy like me, pretty tall. I don't look up to too many people in the world, but he's also got a sick, twisted sense of humor like I do, and I think I'm always one people that I remember lots of things about lots of people. You ask my daughter and my wife about this, as I remember all sorts of things about all sorts of people. Anyhow, the side of the story is that good Dr. Nick was coming up to Canada to take these samples, and he was going to do it in person. And at the time I had warned him, I says, Nick, you're coming up here in Canada and it's winter time. And Ian knows where this story's going because he was there too. He was the one that was actually there. Anyway, I said, you know, it's winter time, you have to dress appropriately, this is Canada. And I got lots of self-assurances from him that yes, everything was fine, I've got the proper equipment, and I've got the proper footwear and clothing and everything. All I could hear about later was cold feet, frostbite, and things that just didn't necessarily go well. That he was hot-footing, or cold-footing. I think Alex, you were out there at that.
I drove him back.
You drove back, so you got to hear all about this. So, in addition to any gifts of appreciation that we give you for coming up here, I also have brought something for you that I hope you will be able to take, not necessarily take with you, but these are for your personal use and rental when you come up to Canada. And these are good genuine -100-degree winter boots. And so when the good doctor comes up to get you, we know you've got some warm for. Anyway, all the fun aside. Another reason why I like this guy is because he's one of these guys like me that likes to take science and turn it into something useful. Pure science is something that is good, and laboratories are fine, but we got to turn it into something useful in the field. And I think that's what he's on the right track with a lot of what he's doing here. This is a major interest to all of us, and I will turn the microphone over to him and let him give his discussion about his current work and research relating to DNA testing and live animal testing. And give a warm welcome for the guy who's traveled the farthest to get here, Dr. Nick Haley.
Well, thank you, Harvey. I wanted to first thank my wife. She's not here, but we have a 3-month-old, and I've been gone for about 4 out of the past 5 weeks. And her patience, I think, is wearing thinner than the hair on my head. So I wanted to thank her and Harvey. A really great group of scientists presenting here today, and I think that's excellent. And I wanted to thank the scientists individually for hanging out here. Some of the work that I'm going to talk about is going to be contentious for sure, and I want to get your opinions on it because I think we're making good decisions here, but I want to hear all the opinions. I may not agree with them, but we can discuss that. I have my email address up here, nhaley@midwestern.edu, because I know we're not going to have enough time for questions, and I want to have that there so that you can feel free to email me and present any questions that you have. So I've been working with the deer and elk farming industry for a few years now. I started out at Kansas State University working with Sean Schaefer and the North American deer farmers, and Travis Lowe and the North American elk breeders. And I've since moved to Arizona in Phoenix, and so yeah, so it's quite a different environment than up here. The frostbite, I got a boot full of snow right up the bat, so that wasn't a good way to start. But anyway, so my map is not the most current. I started working on this presentation in January or February, and the point that you need to take from this is that it's not getting better, right? All of these maps are different because the endemic areas and the number of cases keeps growing. Despite our best efforts, despite depopulation or herd reduction, the problem is getting slowly and continuously worse. Now we have cases in Norway, new cases in Texas and Iowa and Minnesota and other states as well. So that's the important thing that I wanted to bring from this slide. One thing that we've kind of discussed is that we know that CWD is readily transmitted between farm cervids and wild cervids. That's something that the USDA won't let me say. I can't remember if the CFIA will let me say that or not, but we know it to be true. We know it can go both. We know it can go both directions. So that's something that we need to take into account when we're trying to manage this disease. As far as diagnostics, a lot of you already know this information. So we're looking at a post-mortem sample collection of brain tissue and lymph nodes. And we use a test called immunohistochemistry. This test has been approved by the USDA and CFIA. We've also got an ELISA test that has a little bit of a higher throughput and maybe a little bit cheaper. So both of these are kind of approved at this stage. One interesting thing about the OBEX, when we look at that by immunohistochemistry, we can kind of stage these animals. So, this disease isn't either infected or uninfected. We have different stages of infection, early, middle, late, terminal stages of infection, and we can kind of categorize each animal based on what stage of infection they're in by looking at the OBEX. I'll talk a little bit about that. As far as live animal testing, this has been my biggest focus of research for the past few years. My PhD was looking at transmission and early detection in bodily fluids and any sort of tissue, really. And that's been the bulk of my work, and I'm trying to take that research and actually apply it and do something with it and learn something. I've been looking a lot at rectal biopsies. Other groups can look at tonsil biopsies, or there's even a company in Texas now that is attempting to do retropharyngeal lymph node biopsies. The reason I work with rectal biopsies is because we can collect these samples very quickly, and I'll show you exactly how quickly we can collect those with a minimal need for equipment. We're basically using a pair of scissors and a pair of forceps. And disposable, it runs less than $5 for the equipment per animal, and we can collect the samples in 2 to 3 minutes with no anesthesia and no relative risk for the animal because of that. The problem with the antemortem tests that we're working on, I think they're very good, but they're, as most of you know, they haven't been approved by either the USDA or the CFIA. And they have their reasons, and they're good ones. But at the same time, I think it's time we need to start legitimizing these tests and start using them for things that we can appropriately use them for. I'll also talk about the PRNP gene. So everybody knows about the gene that primarily affects susceptibility and resistance in deer and elk. And I'll talk about that. You know, we know about 132M and L in elk and 96G in S in deer, and there are a number of other different genotypes in both species that might be affecting resistance and susceptibility. But I want to try to show you that we talk a lot about this gene, but that doesn't mean that that's the only gene that affects susceptibility and resistance. You know, it's there are multiple genes that you know, say how if a person has Alzheimer's disease, for example, there are a number of genes that affect Alzheimer's disease in people. You know, there's one protein primarily, but life expectancy and that sort of thing can be controlled by a number of genes, and you know, any disease that we talk about, and CWD is no different. So just some photographs here. These are Obeck samples from white-tailed deer. Just showing you how we can categorize the stage of disease in deer and elk. And so, I mean, you can obviously see that the pink is indicative of the infectious protein in these tissues. So, you know, this sample here is just, it's basically pink. So this is what we call stage 4. Not quite as pink, barely affecting these two nuclei here. So that's a stage 3. Down to stage 1, you can barely see pink in those nuclei there. And you know, so that's how we categorize things, and this will be important in a little bit when we talk about how effective the live animal tests are. What we're finding is that our live animal tests are more effective as they get in later stages of disease. So, any sort of testing strategy that we're looking at, rectal biopsies, tonsil biopsies, lymph node biopsies, whichever, they're going to be more effective as the animals are in later courses or later stages of disease. Okay, so some background on live animal testing for CWD. A lot of this is based on work that was done in sheep scrapie. So some of it done here in Canada, some of it done in Scotland, some of it done in the United States. But some groups were looking at tonsil biopsies to diagnose sheep with scrapie, and then kind of moved on to rectal biopsies. In humans, there was some research done on nasal brushes, so we wanted to kind of take the best of all these and see what worked for deer and elk. So in deer, we've looked at tonsil biopsies, rectal biopsies, nasal brushings, and as I mentioned, you know, there's a company in Texas working on lymph node biopsies. We've kind of, I personally have tossed the nasal brushes. They worked very well in people with clinical CJD, but as you know, I've already mentioned, and as you're probably aware, you know, the disease presents in a range of clinical disease. So we can have terminal disease or you know, in very early stages. And what I found was that the nasal brushes worked really well in animals who were in the last, you know, stage 4 of disease, and not so well in stage 1, 2, and 3. And so kind of given up on that. Rectal biopsy seems to be a better approach for me for now. Some limitations of biopsies. Because immunohistochemistry needs a certain size of tissue, we're looking for microscopic anatomy elements known as follicles. And so the bigger the biopsy you take, the more follicles you can find, and the better your ability to identify an infected animal. Well, you know, when we're talking about things like tonsil biopsies or rectal biopsies, it's difficult to collect multiple samples because there's only so many times you can go to the well before the well runs dry. So if we're collecting bigger samples, obviously we can't collect as many if we're doing it every 6 months or every 12 months. So we want to try to, you know, get the smallest biopsy we need in order to diagnose an animal. That's one limitation. Another limitation is that as animals age, there are fewer and fewer follicles, so it's harder and harder as they get older to diagnose them. And you know, that's most important with IHC, and may not be so relevant to one of the amplification techniques that I'll talk about in a little bit. But most importantly, the sensitivity of these biopsies isn't 100%. So as Gordon mentioned, we can identify, if you had 10 infected animals in a pen, we could identify 7 or 8 out of them, out of 10 of those by rectal biopsy. So it's not perfect, but we can still get a good idea of what's going on in that pen. So one problem, the IHC, we need about a biopsy about the size of a U.S. quarter, and so I guess that's about the size of a loonie here. And for the amplification test that we're working on, we need something about a quarter the size of that. So maybe about the size of a pea, and you can imagine that we can get multiple samples repetitively with using a smaller biopsy. But again, we're looking at 75% to 80% sensitivity using these tissues. Now a little bit about resistance, because that's what I'm really interested in. We know, most of you know in sheep that we've developed or identified sheep that are more resistant to scrapie than others. The important thing to remember is that these resistant sheep are not, you can experimentally infect them still, but in natural settings they're not going to get scrapie. And in humans, pretty recently there were some genotypes in people that were identified that are resistant to diseases like CJD and Kuru, which is a disease of people in Papua New Guinea. And so, resistance, we can identify these resistant alleles in humans and sheep, and there's been a lot of work done in deer and elk. Some of it we've talked about. In these resistant animals in sheep, they seem to be either they'll get infected or they won't get infected in natural situations. The problem with deer and elk is that we kind of have a range of susceptibility. So if we have a resistant deer or a resistant elk, for example, that doesn't mean that it won't get CWD. That means that it maybe has 50% of the risk that a susceptible animal might. And one other thing that we noticed is that in those resistant animals who do get CWD, they tend to have a prolonged incubation time. And one of the problems with this is, might mean that they're out there shedding for a longer period of time. But I'll talk about some caveats there. So we know a lot about resistance, but I don't think we know the whole picture, and I'll talk a little bit more about that too. So this is just some background information. This is a study that we did in Iowa and white-tailed deer, looking at the different genotypes and the likelihood that those animals would have CWD. This is in a farm that was about 350 animals. What should be most obvious here is that these 96 SS animals, they were about half as likely to have CWD as the 96 GG animals. So they're more resistant, but again, they're not entirely resistant. There are still some positive SS animals out there. And then the 96 GS, so these heterozygotes, were somewhere in the middle. What I want you to kind of pay attention to, or just keep in the back of your mind, is this sliver of animals here that represented about 10 or 15 animals who did not get CWD. So these are 96 GG, who we classically call susceptible, but for some reason in this herd with such an overwhelming prevalence of CWD, upwards of 80%, these 10 or 15 animals did not have CWD. And so, while this looks very doom and gloom for these 96 GGs, there is kind of a silver lining here, and I want to try to look more closely at those animals. We can't, because all these animals are dead, but in future studies we can kind of try to pay attention to animals who aren't getting CWD. We have a very similar situation in elk. Most of you know we have the 132 MMs and the 132 MLs, and this is the study that I came up for a couple years ago and worked with Alex and Gordon on this project. Something very similar, the MMs were about 3 times as likely to have CWD as the MLs. We didn't have 132 LL homozygotes in this particular herd. We only were working with about 120 animals. LLs are not very common, and there's a potential reason for that. But we weren't able to see, if there were any positive LLs because they didn't have any LL animals in the herd. So going back to that OBEX scoring thing, so I'll talk a little bit, this will be a little bit more clear in a few slides. But one thing that I was noticing, or that we've noticed for a while now, is that when we're looking at live animal tests, like I said, they seem to be more effective in animals who are in the later stages of disease, whether we're talking about a nasal brush test or rectal biopsy test. Those tests are going to work better in animals who are in stages, primarily stages 2, 3, and 4. If the OBEX is negative or the OBEX just has very light staining, our test is less likely to work in that case. And this is from white-tailed deer. The other interesting thing, and again I'll show this in a few slides, the susceptible animals, the 96 GG deer, most of them were in these later stages of disease, stages 3 and 4. So you know, they get the disease and they move very quickly through it and are, you know, very quickly in stage 3 or 4. The SS animals and the other genotypes that we're interested in as far as resistance, most of them were in either stage 0 or 1. So they move very slowly through the course of the disease, and I have a slide in a little bit. There weren't very many animals of the resistant genotypes who were in these later stages of disease, but I have a graph showing that in a little bit. We had the same situation for elk. So the antemortem tests worked a lot better in animals in later stages of disease. The susceptible animals tended to be in later stages of disease. The resistant animals were more commonly in stage 0 or stage 1. So here's just, we've seen kind of a variant of this earlier today, but here's just my take on resistance and what it might mean for agricultural producers. So first of all, again, CWD resistance is not absolute in either deer or elk, at least based on this PRNP gene alone. Like I said, I think there are other genes involved, and we might be able to find some other mechanisms of resistance in deer or elk. The resistant genotypes, if they do get sick, they tend to have a delayed progression. My question is, can we find animals who have a delayed progression that is beyond the natural lifespan of a normal or a farm or ranch raised deer or elk? Can we extend their you know, if they're not showing up positive until they're 16 or 17, and we're culling animals when they're 10 or 11, then, you know, I guess what does that mean for the industry? If we can't tell they're positive, then, you know, how important of a problem is it then? But what I think is that, you know, we have MM animals here who are getting infected, sick earlier in their lives. They move very quickly through the course of disease. We're identifying them as positive somewhere between stage 1 and 2. MLs are getting sick a little bit later. The disease course is a little bit more prolonged. LLs even more so. So these guys aren't getting sick until very late in their lifespan. Some of them are not getting sick at all in the normal lifespan of a deer or elk. So can we kind of, you know, look at this and use it to identify animals who are going to outlive the disease, and you know, maybe they're exposed, but we can never truly identify them as actually infected. And again, just to repeat that the live animal tests that we're working on are very dependent on the stage of infection. It's not so much the genotype, it's the stage of infection. So later stages of disease means better test sensitivity. So best practices as far as CWD testing. So I mentioned a few tests, a few samples that we've looked at. So nasal brushes, we can identify positive animals somewhere between stage 3 and 4. The rectal biopsies somewhere between stage 1 and 2. Tonsil biopsies may be a little bit earlier, before stage 1. Lymph node biopsies, if we're ever able to get any data on that, we might be able to identify them pretty early. But the important thing is that we still have, no matter what test we're using, we still have this period of time here, I mean, I should have a question mark there, where they may be infected, but we have no good way of telling that they're infected by a live animal test. And that goes for any one of these tests. So what it ultimately means is, you know, we can do a lymph node test and give you an answer, but that doesn't mean that the animal's not infected. We need to do a repeat sampling 3, 6, 9, 12 months down the road and repeat that sample or repeat it with another sample. And you know, one additional sample may not be enough. We may need to sample 2 additional times. We don't really know, but the point is that none of these tests are perfect. There's always room for animals being in an earlier stage of disease. So, you know, which test that we pick may not make too much of a difference in the grand scheme of things. So going back to this, you know, this sliver of GG animals who didn't have disease, there can be a number of explanations for why they didn't have disease, but one of them I think truly is that there are other genetic factors involved that may be, you know, turning over proteins at a faster rate, or some other mechanism which could explain why these susceptible animals did not have CWD on this heavily endemic farm. So just looking again, so the x-axis here is the stage of disease. So again, these guys are the 96 GGs. Most of the 96 GGs were in the later stages of infection. GSs was kind of an even split between early and late. SSs, all of them were in stage 0 or stage 1. And then we have some 95 H's who, again, were in very early stages of disease. 226K animals who were, again, in earlier stages of disease. So, you know, what we can do from a production standpoint is, you know, identify positive animals and get them out of the herd, and keep focusing on these animals who, you know, don't progress as quickly through the course of disease. And keep kind of, you know, breeding towards animals who live longer, who can eventually outlive disease. We saw the same thing in elk, where the MMs, most of them were in later stages of disease. The MLs were in earlier stages of disease. So a lot of different genetic combinations that we weren't able to look at. So 226K was a heterozygote. We don't know what happens if we have a 226KK animal, or if we have a 226K animal mixed with a 96S animal. So there's, you know, potentially different combinations that we can have in deer. In elk, unfortunately, all we really know is 132M or 132L. There's no other, you know, mutation, I guess, that we've found that can affect resistance in elk. So what are our options for managing CWD? There's one I left off this list, but I'll bring it up. So we can keep doing what we're doing, quarantine and depopulate, or in the case of wild animals, reduce the herd size. We've seen that is marginally effective to entirely ineffective. We can try to develop a vaccine. So what we've seen so far is that has been ineffective, or in some cases may make the vaccinated animals more likely to develop disease more quickly. Or the one thing I left off is we can do nothing. And with the cuts in NIH budget, USDA budget, I think that's kind of where the US is going to, and that we don't have money to do this sort of research without the help of the industry, like the North American deer farmers or the North American elk breeders, or you know, whoever it is on the industry side. You know, as an academic researcher, I am not relying on the federal government to help us out in these research projects, at least as far as funding. But you know, every day we get emails about from the USDA about CWD in X state or wherever. So it's obviously important to them. It's just not financially important yet. But what I really want to look at is working on genetic resistance. And this is one strategy that hasn't been tried with any real coordinated effort. There have been private deer and elk farmers who have looked at developing resistant herds, but there's been no real project trials or anything along those lines to show how effective it might be or might not be. So why should we even pursue genetic resistance? Well, in the Scrapie model with the sheep herd improvement plan, Scrapie has been reduced in North America, in Europe, by 95% or more in the past 15 years. So we have a model that shows that, you know, genetic resistance to prion diseases in agricultural species can work. It's not going to be as straightforward in deer or elk, but I think the rewards are potentially greater. So that's what I have here. If we can identify animals who are resistant to CWD, the reason that they're resistant might be because they have a higher protein turnover rate. They're able to kind of recycle and break down these prion proteins more effectively than their herd mates. And those sorts of mechanisms are broadly applicable to things like Alzheimer's disease or Parkinson's disease. They're not specific to CWD. They're kind of general protein cleanup mechanisms that may also be useful for developing you know, ideas about Alzheimer's treatment or resistance. And so I mean, it's going to be more difficult, but like I said, the rewards are potentially greater when we're working on resistance to CWD. Third, Mother Nature is telling us that this is appropriate. What we're seeing in different parts of the US is that CWD is shaping the genetics of the herds that it's present in. So CWD is killing off those susceptible genotypes. We're starting to see a rise in the resistant genotypes. So, you know, when you think about the long game, this may be measured in terms of decades or more likely centuries. The long game is that CWD is going to try to kill off as many of the susceptible animals as it can, and the only animals who will be left behind are the resistant animals. Mother Nature takes centuries. Deer breeders and elk breeders, we can do that in you know, 10 years. And you know, what I mean by this last one is that gives the cervid farming industry skin in the game. You aren't just sitting back there waiting for somebody to develop a vaccine or you know, something along those lines. You're actively participating in coming up with a solution for CWD, and that's incredibly valuable, both for those of us working on CWD and for the deer and elk farming industries, because you take ownership of the disease and you're actually making an effort to manage it and eradicate it if we can. So, why shouldn't we pursue genetic resistance? Well, you know, a lot of arguments, you'll hear this from Terry Spraker and Mike Miller, that these resistant animals are typhoid Marys. They are, you know, they take longer to get the disease, they can be shedding longer, infecting other animals. That's important when we have, you know, one resistant animal who's infected among a herd of, you know, 20 other animals, right? That's what a typhoid Mary is, somebody who kind of flies under the radar and infects all the other animals without showing signs themselves. What does this mean in a herd where everybody is a typhoid Mary? If you have a, you know, a fenced herd in a CWD endemic area and all of your animals are typhoid Marys and none of them get sick in 10 to 15 years, I mean, how important is that? You know, this might have importance if you're trying to bring these animals into areas where CWD is not found. But in the herd that we're talking about, that I'll talk about in a little bit in Colorado, you know, our goal is to reduce the prevalence of CWD, and one way to do that is to have, you know, as many animals in the herd be resistant as we can have it. So, let's see. You know, and another argument, so we consider vaccines, right? Well, animals who are vaccinated against a variety of diseases still can become infected and still can be shedding. So it's not, you know, this argument that we should be pursuing genetic resistance shouldn't be overcast by people who want a vaccine, because the same problem can still show up in vaccinated animals. Birds who are vaccinated for avian influenza, for example, they may not show signs of avian influenza, but they can still become infected and can still shed. You know, all of these problems that we see with other conventional vaccines, your common viruses, all of that we can take and apply to CWD. So even if we were to develop a vaccine, it's not going to be a silver bullet. We can still have animals who are infected and shedding and acting like typhoid Marys. The second argument against it is that the prion agent may mutate, and we'll be back at square one, right? So we develop these resistant animals, and then in 20, 50 years, I don't know how long, the agent can mutate and start infecting those resistant animals. We don't have any data on that, right? So we've done this with scrapie, we've created scrapie-resistant sheep. We so far don't really have any data that shows that scrapie-resistant sheep are starting to become more likely to be infected with a new strain of scrapie, for example. I haven't seen any of that data. So right now that's kind of a black box, and I think kind of a red herring for now until we have data that shows otherwise. The other argument is that, well, again, going back to avian influenza, right? This is a virus that mutates all the time. So even if we were able to come up with a vaccine for CWD, that doesn't stop the agent from mutating and infecting vaccinated animals. So what I'm trying to say here is that I think the genetic resistance approach should be put on the same level of footing as the vaccine approach. And we should be putting some effort into that idea, given that it's already been shown to sort of work with sheep scrapie. So we should kind of start looking at it, I think, and giving the same amount of research effort into genetic resistance there. The third thing, I'm sure a lot of you probably aren't familiar with Osborne-Dale Ivanhoe, but some of you might be. So this was a bull, a Holstein Friesian bull that was used as a sire for thousands of animals in about 50 years ago in the US. And it was because he produced cows that were really great milkers. The problem was it took about 5 or 10 years to realize that he had a gene for a disease known as bovine leukocyte adhesion disorder. So all of his cows had this genetic issue where they weren't effectively mounting immune responses. So while they were great producers, they were basically immunodeficient. We don't want to do that with these animals. We don't want to look at genetic resistance and focus on resistant animals and ignore whatever problem there might be in these animals that, maybe they are more likely to get hit by a car or something like that. I mean, it's really hard to say, but we need to be kind of cognizant of that when we're undertaking this effort. So that kind of gets back to the relationship between this gene and fitness. So I mentioned that the LLs are not very common. The 96SSD are not very common. There's an evolutionary reason why that might be. SS deer represent about 10% of deer in any given population. LLL represent less than 5%. We don't know why that is. If you talk to Mike Miller, or if you talk to some sheep breeders 15 years ago, resistant elk, resistant sheep just don't look right. And that's their excuse. They have no real basis for that. They just don't look right. Like I mentioned before though, while these aren't very common in any given population, we do know that they increase over time in areas where CWD is found. So, and our herd is a good example of that. We're seeing over twice as many LL animals and ML animals that you would expect in any given herd, because CWD has been pressuring the herd enough that the MMs have been dying, and the only ones left behind have been LLs and MLs. So to get into the project, that was a long-winded background. Most of you are probably interested in the project. So we're working with about 450. Last year we had 470. This year we had a little over 400 head of elk on 3,500 acres fenced in a CWD endemic area. Based on historical estimates at harvest, we expected the prevalence to be somewhere between 10 and 20%. This particular ranch has a yearly inventory in March in a fairly modern handling facility. So we can run the animals through very quickly and collect our samples and then decide what to do with the animals when we get our test results back. Project objectives, we wanted to continue working on animal testing. We've been doing a lot of animal testing research, but not really applying it anywhere. And this is the first time we've been able to apply it. We wanted to use that to identify CWD positive animals and then work with the State Department of Agriculture and the ranch to decide what to do with them. We wanted to learn more about the relationship between CWD and an animal's genetic background, kind of confirm the things that we already knew about 132M and 132L, and see if we could identify, why 132L animals are less common, and are the bulls less dominant? Are the cows not having as many calves? Try to find an explanation for that. One thing an idea that kind of popped off on the top of my head was, maybe we can develop a herd pedigree. This is a semi-free-ranging herd. We don't know who's related to who, but can we use genetics to identify, to build a family tree, and use that information from an animal genetics and animal, reproduction standpoint, and see how we can kind of fill in circles and squares and see who's getting CWD, and see what we can figure out from that. And I'll show you some information from that. One of the other important things that we wanted to do was look at the economics of managing CWD. So we want to see if this is something that's practical on a 5-year plan, for example, or does it make more sense to go in and depopulate? Are we just wasting money trying this, or is it actually financially responsible to do something like this? The second year of the project, we revised our live animal testing strategies a little bit. We started to develop a better understanding of longevity after a CWD diagnosis. So if we identify rectal biopsy positives, did they make it to the second year or not? We gained more information on the relationship between CWD and the genetic background and reproduction. One thing we wanted to start doing was protecting those LL animals, because unfortunately during last year's harvest season they lost 3 LL animals to hunting, 3 LL bulls. We lost another calf during handling this year. So, when we're starting with 30 LL animals, the loss of 3 or 4 or 5 animals is a pretty big hit, and we'd rather avoid that if we can. And then also we wanted to, continue expanding on the herd pedigree and trying to refine our model for genetic resistance. So we're working on this model, and I'll talk a little bit more about that. So what was working? The rectal biopsies are working great. And I'll show you, how quickly we're able to get those. Feces, we've been collecting feces. So Scott, if you need feces, we're way easier to work with than the CFIA. We can give you as much poop as you want. The contingency might be that you'll have to drop PMCA and have to start working with RT quick. What isn't working? Well, we collected a lot of blood. We wasted a lot of time collecting blood and handing that out to different partners. Nobody's doing anything productive with it, so I don't see any reason to continue collecting blood as a diagnostic test right now. Oral swabs is not working. That's a relatively easy sample to collect, so we collected that again this year, but we probably won't get it next year. Skin biopsies, again, kind of a difficult sample to collect. Nobody really made any progress with it, so we dropped that. We looked at things like body condition scoring too, and I'll talk a little bit about that in a second. We tried to get weight estimates, but elk, it turns out they don't like to stand on the scale. They don't like it when you put a weight tape around them very much, so we didn't get very far with that. One other thing we'd like to do is look at antler score estimates. We'd like to see, we want to give the ranch information on what their bulls are scoring, and we also want to look at the LL animals and see if they have good scores. If that's something, if all of the LL bulls have really small antlers, well then the ranch isn't going to want to pursue that, right? So we want to make sure that the LL animals that they have or that they're going to be importing have, are trophy quality animals, because that's important from the production standpoint. The body condition scoring, we'll do that again, but we didn't see any relationship between body condition score and CWD status. What that means is that we couldn't look at an animal and say, that animal's thin, it has CWD, because a thin animal was just as likely to be positive as an animal in good body condition. So body condition wasn't a good way to predict whether an animal was infected or not, but we'll keep doing it because I think it's interesting. Okay, so antemortem test development. Year 1, we sampled 465 animals. Year 2, we sampled 400 animals. There's a reason for that drop. Most of you can probably guess why that is. The RT Quick turnaround. We had all these samples processed in 3 to 5 days by RT Quick in year 1. In year 2, we took a little bit longer because we were running over a weekend. Prevalence based on RT Quick in year 1 was about 16%. In year 2, it went up 5%. So this is not the direction that we want to be going. I was a little bit discouraged by this, but we'll try to look for silver linings there. We can also group animals into suspects versus RT Quick positive. So we had about 5% that were considered RT Quick suspects. IHC turnaround, closer to week turnaround time there. Prevalence was much lower based on IHC, about 8.5% in year 1, and then up to 17% or so in year 2. So, the question is, IHC is the gold standard. Are we beating the gold standard, or do we have a lot of false positives by RT Quick? And I'll talk about that in a second. Because we know that either of these tests are only about 75% sensitive, so we're missing 2 or 3 out of 10 positive animals. Predicted prevalence in year 1 was about 20% by RT Quick, 27% in year 2, 11% by IHC, 21% in year 2. And that's, again, kind of in the range of what we were expecting based on harvest data. We knew it was somewhere between 10 and 20%. So this is just a picture. This is an animal that was culled last year. The biopsy collection site was about there. In 3 days after the biopsy, the mucosa was completely healed over. One of the concerns of the rancher was, we're going to be collecting these biopsies, the animals are going to die, they're going to bleed out, they're going to, perforate their abdominal cavity or something like that. The truth is that these biopsy sites heal really fast. There's no reason for concern there. One problem I think that we ran into with IHC was that, again, older animals have fewer follicles, or we collect a maybe not so good sample and we don't get as many follicles as they want. So, in those particular samples, and Gordon can attest to this, if you don't have a good sample, it's hard for IHC to say whether it's positive or negative. As far as RT Quick was concerned, we got a lot of good results in animals who didn't have very good follicle counts. So I don't think follicle counts matter very much when it comes to the RT Quick test. And I'll talk about that too, I think, in a little bit. Okay, relationship between this PRNP gene and infection status. The prevalence in MM animals in year 1 was about 21%, in year 2 was about 37%. MLs, they were about half as likely as MMs to be infected in year 1, a little bit less so in year 2. And LLs, again, the first year we had about 30 LL animals and none of them had CWD. In the second year we have one positive animal, an 11-year-old cow. So the average age, again, the MMs, the average age of a positive animal is about a year younger than a positive ML animal, and we only have this one animal to look at here, but she was 11, like I said. If we look at the odds ratio of infection, so if you take any given animal, how likely is it that they'll have CWD, and we kind of pin that all on MMs. MMs have an odd ratio of 1. MLs are about half as likely to have CWD, and LLs are somewhere in the 10 to 11% range of their relative risk of having CWD, I guess you could put it. So, we're trying to convince the owners that they need to focus on these LL animals. Not too much, but enough, because one of the management goals is to have CWD prevalence reduced on this farm, on this ranch. And one way I think we can do that, I mean, if every animal on the ranch was LL, the prevalence I think would be a lot less than it is right now. But we don't want to move that direction too quickly. But at the same time, we don't want to be harvesting the LL bulls in the fall. So what we wanted them to do was put some sort of recognizable ear tag on those LL bulls. They kind of declined that. I think one of them has a recognizable ear tag. The rest of them don't. And the reason is because they want trophy quality bulls. If we have an LL bull and it wasn't trophy quality, in their minds it wasn't worth keeping that animal one way or another. Another thing that we did manage to talk them into was, can we siphon off all of the LL cows and some of the older productive ML cows into a separate pasture, and then at some point import you know, 2 or 3 trophy class LL bulls and kind of use that as a seed stock operation for the ranch. So, you know, we're you know, cultivating that L allele, and we can release those animals onto the ranch so that next year, instead of having 5 LL calves, they have 10 or 15 LL calves. And we'd like to be able to do that every year if we could, as long as the ranch is interested in pursuing all of this. But at the same time, we want to consider long-lived MM and ML animals. So we have a number of older MM animals and older ML animals, 15, 16 years old. How did they make it so long in the face of 20% or higher prevalence rates of CWD? There must be something about them that's keeping them from getting CWD, and we want to kind of continue cultivating those animals if they'll be productive. IHC positive cows, so these are the animals that they ended up culling. We wanted them to cull every positive animal, whether it was IHC positive or RT quick positive. From you know, a producer's perspective, they were very hesitant to cull positive bulls because each one of those bulls represented $5,000 to $10,000 or $15,000 dollar signs. So to just cull them in March and not hope for harvesting in the fall was you know, contradictory to their business model, I guess. But you know, from that we were able to kind of look at survivorship of those animals, and I'll talk about that in a second. All of the RT quick positive animals, well, we were hopeful that we might be able to check them at inventory this year if they made it that far, or if they were harvested, we could also get their status at that point. This is just a picture of the IHC positive cows that we pulled aside last spring. So again, very hard to visually identify them as positive. One of our initial suggestions from Mike Miller was, you know, oh, you can just go out and look at them and see who's positive and selectively remove those. Well, we would have been really, really non-specific about removal if we had undertaken that. So, you know, again, it's really hard to identify the positive ones by sight. So here's kind of the more important stuff. So IHC positive, we had 14 positive bulls who were turned out in the pasture and onto the ranch after inventory last year. None of those positive animals were harvested. They didn't even make it to hunting season. None of them were returned to inventory this year. So while the ranch hoped that they would be able to recover some monetary investment in those animals, they all died probably before hunting season. So we weren't able to tell whether they were positive or not. You know, the most important thing to remember there is these animals probably won't make it 3 or 6 months if they're identified as rectal biopsy positive. So, you know, we're hoping to convince them to cull these animals in future years. We had 31 RT quick positive animals last year that were turned out on the ranch. Only 12 of those returned, and 10 of those were IHC positive. So, you know, there were two animals here which were RT quick positive that were probably false positives, and I need to go back and look and see, you know, we can RT quick kind of provides you with a range where you can draw a cutoff line and say these animals are positive, these are negative. We might need to adjust our cutoff line, and these 2 animals might be, you know, we might have to move them into the negative based on whatever their scores were on RT quick. But so, you know, the idea here is that I think that RT quick is more sensitive. Otherwise, why would we be pursuing this sort of new diagnostic test? In reality, I think that IHC only has a sensitivity of somewhere between 60 and 70%. So, and that doesn't just apply to rectal biopsies. I think that applies to any sort of post-mortem test that you're looking at today. So, sorry to say that, Gordon, but I think that you know, if we had 10 infected animals in a pen, IHC, post-mortem IHC would only be accurately identifying 6 or 7 out of those. There are a number of animals who are, you know, just at that stage, early enough in infection where they're not positive by IHC and they might be positive by RT quick. We had 21 RT quick suspects. One of those was harvested. Only 18 of those 21 returned. and half of those were positive. So we have kind of a fair cutoff line here between positives and RT-quick suspects. So there is some number of these suspects that do turn out to be positive, but we need to kind of adjust this line. Perhaps some of these two animals here should have been dropped into a suspect. We'll see. The other thing is MM animals versus ML versus LL. An MM animal, if it was positive, had about a 1 in 5 chance of coming back. And ML animals, all this graph, or all this chart really shows is that an ML animal is more likely to make it a year than a positive MM animal. So that's, I guess, one thing to keep in mind with resistance. We want to look at pregnancy rates, so we wonder why there are fewer NL and LL animals in natural populations. Perhaps the LLs aren't as likely to get pregnant or something like that. The overall pregnancy rate on the ranch was pretty low, between 60 and 70%. Normal pregnancy rates in elk populations that I'm aware of, based on published reports, is somewhere around 80% or higher. So it's kind of low, but what we found were that the MLs and the LLs were just as likely to be pregnant as the 132 MM. So there's really no effect on pregnancy with regard to their genetic background. So from that standpoint, it still makes sense to breed LL animals. That it's not like they're having fewer calves or something like that. Developing a herd pedigree. So we're using some technology that's commonly known as DNA fingerprinting to identify animals and then use that information to identify who that animal's parents are. And the purpose, some of you might remember from high school biology, this is a pedigree of the British royal family 300 years ago or so. And these are, the red individuals are those individuals who had hemophilia. I wanted to try to do something like that for CWD to see if we could identify lines of animals here who were more susceptible to CWD than others and build off that information. So here's the pedigree from year 1. It's pretty large. This is a model pedigree. This is the software that we use. It's not a perfect model, right? There's going to be some errors in here, but this is the best model we could make with the information that we had. And so this is actually year 1 and year 2 of the pedigree. Some things you'll be able to see, maybe even from the back, but definitely up close, is that we have, here's a cow with CWD, her calf has CWD, her calf has CWD, her calf has CWD. A cow here with CWD, her calf has CWD, this other calf has CWD, this calf has CWD. There's potential for genetics to be playing a role in that. There's also the potential, most of you who have elk hunted or are really familiar with elk know that cow-calf operations, cows and calves tend to sort of live in the same environment. So it may be genetics, it may be that they're sharing similar environments, but it's still something that nobody really has done yet that we're going to continue looking at. But like I was saying, we can focus on these groups of animals and see how these lineages of animals are more likely to have CWD, for example, than these other lineages of animals here. So this dark blue, these are MMs. This lighter blue is MLs, and then we have a very light blue that are LLs. But here we have some MM animals who are related who don't have CWD, and what's so special about those? I'll answer your question at the end.
I don't want to lose it though. Is this based on DNA?
Yeah, so this is all DNA fingerprinting. We're using microsatellites. There have been, we're using a protocol that was developed by a woman with California Fish and Game, who she works in forensics with fish and game in California, and so we're using that protocol to build the pedigree. And from this pedigree, we can look at things like reproduction in susceptible versus resistant animals. So we can look and see, if we have an LL cow, how many calves does she have? If we have an MM cow, how many calves does she have? One thing that we found was that adult ML and LL cows have more calves on the ranch than MM cows. This is probably because MM cows might be having MM calves who are more likely to get CWD, so they have fewer calves because the calves have died of CWD already. But just on the face of it, we're seeing that ML and LL cows have more calves than an MM cow does. On the flip side of that, we're seeing that MM bulls have more calves than an ML bull or an LL bull. So, this thought that this genotype might be related to fitness in elk and deer, it may be more related to bulls than it is to cows. So it may be that MM bulls are more dominant, or they have better sperm quality, or any number of factors that we can look at some later point to explain why MM or M animals are more common than L animals, for example. What I really want to do with this pedigree is if we throw a dart and hit the board and look at a specific animal, if that animal has CWD, what's the likelihood that its calf will get CWD? Or if that animal is negative, how likely is it to get CWD based on the fact that its mother had CWD, its grandmother had CWD, they have a half sibling with CWD? So, we can use animal genetics to analyze this pedigree, mathematically, and assign values to different animals as to whether they're more or less likely to have CWD based on the animals who are related to it and whether they had CWD or not. So, for example, if an animal has 5 relatives with CWD, maybe that animal is more likely to get CWD than another animal who has no relatives with CWD. And so we can assign values. The sort of metric that I've come up with is what I'm going to refer to as RISC, R-I-S-C, and that's the relative index of susceptibility to CWD. So any of you producers who have ever heard of estimated breeding values, it's the same thing that's being used to develop better milking cows or develop beef cattle that are better growers, that sort of thing. So we want to try to identify animals who are less likely to get CWD and try to weed out the animals who are more likely to get CWD before they actually get it, if we can. And I talked about this a little bit. We have several older NM cows who have uninfected calves on the ranch. So while they're susceptible, what we classically consider susceptible, how did they get to be so old, and why aren't any of their calves getting CWD? At the same time, we have some really young ML animals, so 2 years old, who have CWD. So why, if we consider an ML to be more resistant, why are they getting it at 2 years old? So we want to try to cut out these younger animals that get CWD even though they're resistant, and try to maintain these older animals who don't have CWD even though they're susceptible. Finally, management. Management is so the cost of everything is heavily dependent on whether we provide indemnity. This particular ranch is not getting an indemnity, so it's kind of irrelevant. And whether prevalence rates are increasing, decreasing, or stable. This is kind of a very basic chart here. In our case, prevalence rates seem to be increasing, but when we look at this sort of model, even if you're providing indemnity, so however much that is, in the U.S. where we're currently providing about $3,000 per head on these CWD pops, even with that, managing CWD in an endemic area, if the prevalence is stable or decreasing over the course of 5 years, it's still much, much less than the cost of your average depopulation. If you're not providing indemnity, it's a fraction of depopulation. So financially, it makes a little bit more sense to kind of try to manage these and pull out positive animals as we can, whether you're providing indemnity or not, I think. So where do we go from here? There are some drawbacks to the current project. The first is that we're only sampling on a yearly basis, so we only get to pull animals once every year. The second is that we can't control who's breeding. This is a semi-free ranging population, so we can't control, whether LLs are breeding the MLs or what, except for the fact that we've kind of pulled some of these cows out and are trying to encourage that particular allele in this herd. The third and most important is that conservative management is probably slowing progress. So we're telling the ranch that they need to pull the positive bulls, they need to pull the RT-Quick positive animals, but so far they've been resistant to that. I think we might make a little bit more headway if we were less conservative about how we're managing this particular herd. The benefits, I think that we're showing how management could work in a CWD endemic area. We're also, what I think is really neat is we're working with semi-free ranging animals, so a lot of this information that we're getting can be directly translated to wild deer and elk. There are some subtle differences, but for the most part, these animals are free ranging. So a lot of that information is transferable. The high level of prevalence helps drive selection for resistance. So if you were developing a drought-resistant crop, would you want to do that in an area where there's a drought or where there's a lot of water? In this particular herd, we have a high rate of CWD. The only way we're going to find resistant animals is if we have a 20 to 30% prevalence of CWD there. If there wasn't any CWD, it's impossible to find who's resistant to it. So that high level of prevalence is actually helping that process, I think. The last thing is that these animals are fairly easy to handle, and we can collect samples very quickly. So I don't think I mentioned it, but we're running animals at a rate about 1 every 2 to 3 minutes. So the ranch thought it was going to take us 3 weeks to finish the inventory. Instead, we're doing it in 2 or 3 or 4 days. So they're very happy about that. So in summary, I think that more intensive management is going to make this project more effective. However, we have to deal with the constraints of the ranch. More frequent testing and expanded culling would help. Controlled breeding, if we can keep that up. Systematically evaluating the pedigrees and finding resistant lines of animals. Try to look at other potential markers of resistance. So if we had a SNP panel or if we knew other genes to be looking at, we could potentially link those to resistance. If we had a ranch that had in vitro fertilization or could do embryo transfer, we could transfer a lot of this information pretty quickly. But as it is, we're still able to transfer the information that we're learning here to other farms and the wildlife side of things. But I think the best approach to solving the problem that is CWD is one that has been used to improve livestock for millennia. So we need to let deer and elk farmers do what it is they do best, breed animals based on specific traits that they like, and removing animals with traits that they don't like. In this case, the trait that we don't like is getting CWD. The trait that we do like is being resistant to CWD. And I think that we can breed deer and elk with enormous antlers in a few years. We can do the same thing, I think, with CWD. We can make a lot of progress very quickly with the help of the deer and elk farmers. So with that, I'd like to quickly wrap it up. I have Sarah Wyckoff, who's that student that worked for me, the Colorado Department of Agriculture. So a lot of this is being routed through the State Department of Agriculture. The USDA has been very hands-off, other than helping us with some of the IHC. So Bruce Thompson and Aaron Lemkel at the USDA, CSU, Rocky Mountain Labs, Iowa State University. These 3 labs are all repeating the rectal biopsy testing that we're doing, so we can see how so we can validate RT-Quick among a bunch of different labs and show that it's reproducible. I have CFIA in question marks here because I'd like to invite Gordon and Stephanie Chubb, who maybe they have RT-Quick capabilities. We'd like to kind of send these samples your way and have you guys validate them up here because I think it's a worthwhile approach to be looking at RT-Quick and other amplification methods. So that's all I have.
Okay, question time. Catherine's got her hand up first.
Yes, I just have a question about, I guess, the genotype within the population itself. is at a low prevalence, and the fitness, and just pointing out that fitness behind the fence is not the same as fitness outside of the fence, and it may have something to do that you can't pick up between the fence. For me, I'm working on the wildlife management side, and the husbandry, in terms of moving toward that selection, is fairly easy in the fence, very difficult outside of the fence. And I guess it depends, if we're talking about in a natural setting, evolution takes a long time. These individuals are low prevalence in the wild, genetically. And I guess when we're talking about those rewards that you were talking about, I would like to hear from others, what are the rewards for the wild? Because resistance is not the same as proof, just like waterproof. Something is not the same as water resistant. Disease is still going to affect those. CWD, all those individuals will eventually come down with it. And I'd like to know what importance do we put on the wildlife so that we can manage this disease as a whole rather than one against the other and one over the other. And I'd like to hear that from others.
I agree, yeah. So it's going to be difficult to translate a lot of this. We can, provide wildlife with the information that we find, but it's going to be hard for you to act on it now. But in the future, there may be ways to identify, resistant animals remotely, either through collecting field samples, to try to identify resistant animals that way. My goal, I think, is, as I mentioned, CWD can go both ways on the fence, into the farm or out of the farm. And what I want to do is help the deer and elk farming industries to remove that from the equation, remove them from that equation, so that we're not moving ranched animals and having that contribute to the spread of CWD. Managing the disease in wildlife is going to be hard no matter what.
I just making that comment again, the connection that you made, that the fence does not create a barrier from outside in or inside out. We have to work together if we're going to manage the disease. And the animals, even if they are resistant and they continue, not that I'm trying to be a typhoid Mary here, but that they are still spreading the disease, and through the water column or whatever means there are, it's moving outside of the fence, and we still have a problem outside of the fence. And is there a way we can all work together to manage this disease in a way that's beneficial to our ecosystems and our environment as a whole?
I agree, and I guess what I'd like to say to that is this only makes sense to do in areas where CWD is already found. We need to kind of do this in test areas where CWD is 10% on the outside of the fence and 10% on the inside of the fence. Does that make sense? I don't think it's necessarily appropriate to do in Ontario, for example, or to be moving these animals to Ontario.
Yeah, Sean.
Okay, Sean, you got it.
You asked where this could be applicable to the wild. Well, we've got 4 different states, I think, we're up to now, and I don't know what they're doing up in the provinces, but they're willy-nilly jumping elk all over America. And I guess if you're going to take elk and bring them to a new area, Wisconsin, Pennsylvania, Missouri, well, at least bring the resistant ones. So we could do this to, you're not going to do it on a large scale up here in an area where you have elk, where you have deer, but at least if our wildlife agencies are going to be moving animals around and relocating them, couldn't you at least test them and find out, number 1, do they have disease, the live test there, and then number 2, maybe at least move the LLs. To me it makes sense more than moving up infected animals.
Yeah, and so far none of that's been done. No relocation of elk. None of them have even, and I've approached them. Can we test these animals before you move them? Nope, sorry, we don't want, we don't want to implicate either Kentucky or the animals that we're moving in as potentially being infected. They haven't done genetics, so from my perspective, wildlife has been very resistant to health.
Okay, Ian was next. Got a microphone there, Ian?
Yeah, Graham was next.
I'm from just outside Riding Mountain National Park. And so I've been very familiar with the approach they've taken trying to get rid of PV there. And in terms of your questions, Catherine, then if you've got lots of budget, then fly with a helicopter, capture deer, put a collar on them, test them, go back, the resistant ones, you capture them again. Okay, but just let me, this is what they did in Riding Mountain, they spent $20 million. Okay, but okay, they capture them, and they leave the ones that are negative. In your case, you leave the resistant ones, put big pink tags in those bucks' ears, and then put it in your hunting boat, and do not shoot pink tag animals. They are resistant to CWD. Well, that's one idea, it's a little fanciful. But anyway, here's the next idea. When you're doing your head testing, do a $100 genotype on them, and you may identify areas of animals that are resistant. Then you could reduce hunting pressure in those areas, allow that little micro-population or family to increase, and allow them to repopulate areas surrounding it.
I guess what my question is, can we manage it in the wild without having, it's no longer wild if we're doing this. I'm wondering, can we talk about managing in the wild and doing things that were brought up earlier, our grain bins, agricultural practices on the landscape, where we take better, if we use Randy's words there, the biosecurity in the wild, and we clean up some of our practices so that we can do this in a more a natural environment.
I just want to say that I am all for helping wildlife. That is my.
And just so you know, we don't move elk. We're not moving elk. We're not doing those things that might be happening down south. The idea that we would ever have a budget to do that sort of thing is, from some science fiction movie. But
we're all in the same boat.
But I'm just hoping that we can find solutions that we can all work together, and that's what I'd like to hear from people. And I don't know if everyone, if we can become siloed and we only think about what we have in our backyard, it's one thing. But if we can work together and think about the bigger backyard, we might get somewhere.
First step to that is we're all here today.
Thank you.
I guess
I got one. Sorry, Bruce. I got one ahead of you.
Sorry, we might have got a little bit on a tangent there. So my question isn't specifically related to the resistance. It's more related to management of known positive herds. I think you have an opportunity here to look at that as well. We heard earlier about there were 4 herds in Wisconsin that are known positive that are being allowed to continue operations. I'd be interested to know whether you looked at any kind of environmental sampling. We heard from Dr. Bollinger about the dose-dependent relationship of the disease, whether managing known positive animals in a fenced area will presumably increase environmental prion load over time. And I actually, maybe it's not related to that, but I would be interested in whether or not that would have a relationship to increasing prevalence in that herd over time, related not necessarily to their resistance, but increasing dose of prion.
Yeah, so that's a good question. So every ranch that I've been involved with, either as a depop or this current one, we're sending out environmental samples too. So soil samples, plant samples, water samples, feed bin samples, you name it. I'm reluctant to keep taking those samples because we send them out and nobody does anything with them, right? And so, we can do PMC air quick, and I'm kind of skeptical of some of those results. But, if nobody's doing anything with the samples that we're sending them, it makes it hard to, consider collections in the future.
Okay, Bruce?
I guess getting back to her point, and it's different with deer, mule deer and whitetail, but in elk, when you look at the Canadian situation, Elk Island National Park has a world-class animal facility, and they've been the source of translocated animals to go in many different directions. And once you build a model, I think what you'll find, Nick, if you can get it right down in Colorado and we can copy it in other jurisdictions, you can apply that to, these wild translocated situations. To be blunt, I think there'd be a huge benefit. Because, if I remember the stats, there's been at least 20 translocations in years past coming out of Elk Island. So to be blunt, I think all this technology, working both in the wild, on the farm, I don't think anybody wants to operate in a silo. Everybody's going to do the best they can, but all this work is going to apply to what's happening in the wild, especially in the elk case. It's hard. Not many people are translocating deer, to be honest, but there are still lots of translocations. There were in the past. And Elk Island's always the first choice when they're going looking for elk to translocate. So it'd be nice, they got a world-class facility, they can do a little more testing.
Yeah, I agree. The reason I'm working with producers and not with wildlife is because, frankly, the producers have been more inviting of having this sort of work done. And second, we're able to get a lot of information very quickly and make a big impact. I've worked with the Rocky Mountain National Park and the National Park Service, and we got more samples in 3 days from this ranch than we got in 5 years from the Park Service. So, for me, it's just we need information and we need it fast. We can't wait 5 years for to collect this number.
Okay, Trent, go ahead.
Yeah.
We'll take, after you, we'll take one more, and then we'll move to the next speaker.
I guess I just wanted to comment on the environmental sampling, and I'm not an expert in any of these PMCA or RT Quick, but my understanding is the issue with environmental samples is being able to extract the prions from a complex substrate, right? So I think it's unfair to say that you take samples and you send it to labs and they don't do anything. It's difficult to extract the prions, and because they have different binding properties in different substrates. That's my understanding of it.
I agree with you.
And if I could go and sample the soils around where I think that they're heavily contaminated and answer the criticisms about my study, I would do that too, but I can't. So that's why they're working on evaluating the CWD agent in feces, but that's taking time because just because you can't detect it may mean that you haven't actually been able to extract it from the substrate.
Yeah, so I'll just say the fruits of our labor have not been realized yet, and I'm reluctant to send somebody another 10 pounds of poop if we don't have results on last year's 10 pounds of poop yet. So, I'm happy to keep collecting samples, but we need to see some progress before.
We got one more.
Catherine gets the last word on this one.
I recognize the work that you're doing, and you put a lot of work into this, and I don't want to downgrade that. But I do ask that you please use caution when you say that wildlife folks don't want to work with you. We don't have maybe the same budget, the same drive for what we're working with, and our sample sizes are very, very, very low because we're dealing with volunteers. Volunteers that are turning their heads in, and our samples are really, really low. But you're welcome, and I extend the invitation to work with you on whatever way you think you can help us. It'd be great.
Okay, I know we all have lots of questions for a good doctor. There's also the roundtable panel, which we'll establish hereafter, but also the good doctor's with us for another day yet. So pin them down after supper in the hospitality room. Give them a chance to sleep tonight. You got all day tomorrow to get with them too. I guess I could talk about it. You want to move that? Okay, back to what we said was the theme of our day today, was charting a pathway. Well, guess where the pathway leads us? The pathway leads us back to Colorado, where this all started. And Wayne's having a bit of trouble there, but I don't know where. Oh, it's under the pocket, so I've got to start a PowerPoint. But I also, just for Randy's benefit, before he walks out of the room, you had mentioned that you were the only one in your here that did not have doctor in front of your name. Well, that's not entirely true, because Wayne does not have doctor behind his name either, in front of his name. But also, you also have to remember what the definition of an expert is. And an expert is somebody that came more than 50 miles to come and talk to you, so you came more than 50 miles, so you're considered an expert.
Sorry, Trent.